Completing the square is a method used to solve quadratic equations and involves transforming a quadratic expression into a perfect square trinomial. This makes it easier to solve for the unknown variable or to understand the nature of the quadratic function. The quadratic equation typically takes the form ax squared plus bx plus c equals 0, and the goal of completing the square is to rewrite this expression so that the left-hand side is a perfect square, which can then be solved easily. To begin, let's first understand how to complete the square when a equals 1. Consider a quadratic equation in the form x squared plus bx plus c equals 0. The first step is to focus on the x squared plus bx part of the equation and ignore c for now. To complete the square, take half of the coefficient of x, which is b, divide it by 2, and then square it. This gives you the value needed to complete the square. Add and subtract this value inside the equation to maintain its balance. For example, with the equation x squared plus 6x plus 5 is equal to 0, half of 6 is 3, and squaring it gives 9. Therefore, the equation becomes x plus 3 squared 9 plus 5 is equal to 0. Simplify this to x plus 3 squared 4 is equal to 0. Now you can solve for x by first isolating the square on one side, x plus 3 squared equals 4. Take the square root of both sides to give x plus 3 is equal to plus or minus 2, and finally subtract 3 from both sides to get x equals minus 3 plus or minus 2, which gives x equals minus 1 or x equals minus 5. When the coefficient of x squared, represented by a, isn't 1, the process is slightly more involved. In this case, the quadratic equation takes the form ax squared plus bx plus c equals 0. To complete the square, you first need to factor out a from the x squared and x terms. For example, consider the equation 2x squared plus 8x plus 3 is equal to 0. Factor out 2 from the first two terms, 2x squared plus 4x plus 3 is equal to 0. Now, complete the square on the expression inside the brackets. Half of 4 is 2, and squaring it gives 4. So, inside the brackets, we rewrite x squared plus 4x as x plus 2 squared 4, giving us 2x plus 2 squared 4 plus 3 is equal to 0. Distribute the 2 to get 2x plus 2 squared 8 plus 3 is equal to 0, which simplifies to 2x plus 2 squared 5 is equal to 0. Solving from here, add 5 to both sides, divide by 2, and then take the square root to find x. The completed square form of a quadratic expression also provides valuable insight into the graph of the quadratic function. The equation in completed square form, a, x plus p, squared plus q, gives the vertex of the parabola. The vertex is located at p, q, which allows you to quickly identify the minimum or maximum point of the graph. This is particularly useful when sketching the graph of a quadratic function, as the vertex is the turning point of the parabola. Moreover, the direction of the parabola, whether it opens upwards or downwards, is determined by the sign of a. If a is positive, the parabola opens upwards, and if a is negative, it opens downwards. In conclusion, completing the square is a versatile method for solving quadratic equations, particularly when factorization isn't straightforward. By transforming a quadratic into a perfect square, you can solve the equation step by step, even when the coefficient of x squared isn't 1. Additionally, the completed square form helps in sketching the graph of the quadratic function, as it reveals the vertex and the direction of the parabola.